Okay, so this is all pre-set up right here for this half sheet for 4L for this video one for 4L video lesson. So if you can, I'm just gonna go across the entire thing here, so you can go ahead and make your markings, make all these preset markings here, and I'm gonna explain all of them. So this side, that side, that side, and same over here, right there. Right there, you go ahead and pause it if you need to set it up. We're gonna finish here, so I'll just set it up all the way here so we can finish just there, so the video is shorter. So let me go ahead and get started then. This is square root quad equations. This is special forms of quadratic equations that you can solve using square root operation. Now I need you to understand something about inverse operations. They undo each other. You know two of them very well. When you add and subtract, those are two inverse operations. They undo each other. And when you multiply and when you divide, they are, again, inverse operations. Now the other one is square and square root. This is the one where you see a square, you undo it by doing a square root. And if you see a square root, you undo it by doing a square. So let's start with this one right here. X squared equals 9. Now, when you square both sides, you're going to notice this. Square root both sides. Because if you see a square, you're going to square root. So these are going to cancel each other out, and you're going to just be left with x. Now, the square root of 9 is 3. But why is this plus or minus here? Well, this is why. You can have 3 times 3 equals 9. Or negative 3 times negative 3 equal 9. They both will give you positive 9. So both positive 3 and negative 3. Therefore, this symbol is used to show that you can multiply either one by itself to get you a positive 9. So they're both valid. They're both solutions to the equation, plus or minus 3. And we know quadratics, they can have up to 2 solutions, so that's for sure the answer there. There are 2 answers, positive 3 and negative 3. Now for this one here, we have then the other side. What if you have a square root? So look over here, square root of x equals 4. We see a square root. If we want to get rid of that, we square both sides. This square gets rid of the square root, so you're left with x. 4 squared is 16. Now for this one, there's only one solution, and it's only 16. This doesn't have a plus or minus. When you do this, you do. When you square root, you do. When you square, you don't. Okay, so that's the only solution to that equation, 16. All right, so we notice the 2 solutions, right? When the symbol plus or minus, and then there's this other condition that you cannot take the square root of a negative number. It's undefined for now. So we'll get into that very soon after in the ending of the class. So for this one here, I need you to understand you're always trying to solve for the variable, so you're working around anything else to get to it. Minus 10, you get x squared equals 36. So you can see a square, so you must square root. It cancels it. It square root everything. And then on this side is 6, but remember, because of this rule, it's plus or minus 6. They're both valid. And then let's go over here. To solve for x squared, you multiply both sides by 2. You get x squared equals 9. And again, you square root both sides. You get plus or minus 3 for that one. Over here, this is the one we want to show you about undefined. So you have x squared equals negative 16. And then let's go ahead and let me show you that result there. And there you go. The square root of negative 16 gives you an error. And then that's where it goes, error, right? Yeah. So, no solution, undefined. X is undefined. No solution for now. We'll leave it like that. Moving forward, here we can have a simplification of radicals. Now we got to make sure how to simplify some of the radicals. Some radicals you can simplify, some you can't. Like this one right here, you can't simplify this one because if you solve for x here by dividing out the 3 first and then square rooting, you get the square root of 5. Now the square root of 5, you can't simplify to any more simple radical. So you just go ahead and you just leave it there, like plus or minus the square root of 5. You leave it like that. But when you get to something like this, when you divide out to 2 here, and then you have x squared equals 20, that square root of 20 can be factored into the square root of 4 times the square root of 5. Now, two radicals like that, they do factor out like into radicals, just like that. Just like the number 20 would factor into the 4 and the 5. If it's a radical, it does the same thing with the radical. So now there's a simplification you can do because you have a perfect square with this guy. This guy is a perfect square, turns to 2, and this square root of 5 stays as square root of 5. But I forgot here to add my plus or minus, because when I square root, technically this had a plus or minus already here. So as soon as I square root, I generate my plus or minus, and it stays with me till the end. And this had a plus or minus right here. Now let's go ahead and finalize this video. So with a 32, I can do this. Let's square root both sides, and let's go ahead and finish up this video. So square root, okay. This will cancel this, so x will equal, but right here, I want you to see how this guy factors out into this and this. The square root of 16 times the square root of 2. Now, I purposely picked 16 because you're looking for perfect squares, the highest perfect square you can possibly get. So the answer for this will be x equals 4 radical 2, and I'm missing my plus or minus again, so let me put that in red. Plus or minus as an answer. There you go. That is the answer for there. Now these ones, these are more complex ones, but you kind of get the right idea. So I will work them out, and then you'll see them, worked out in the regular way when I scan this into the website. Now for this one, I want to just show you the first two, like right there. That's how you would do this one. I'm asking you to simplify any perfect square roots to get a simplification here. And that's exactly how you simplify. Simplifying means you're going from here and you're ending up right there. And then here, numerical values of these radicals, plus or minus. If you do 5 plus the square root of 8, you should get this value about. And then 5 minus square root of 8, this value. Okay, so I'll put this up again. Thank you. That's another one.